He is a friend to your industry. He supports it in so many different ways, especially in putting on this conference and the work that he does at the University of Maryland. You all see his bio. It's really very impressive. And with that, I'd like to introduce Dr. Doss.
Good morning. I conspired to move Sultan to the next session so that I can have more time to speak. But with that, thank you all for coming here. I know some of you had to really travel, made travel arrangements and changes to get here. We got off really easy in Washington, D.C., so I have nothing to complain about. I'm from University of Maryland. I'm from East Coast, so I have a little bit of accent. Bear with me on that. But in terms of the presentation, there is a huge change from the first three speakers and the one I'm going to talk about. Unfortunately, you don't have the copies. I didn't send it ahead of time for that to happen. But it is going to the very nitty-gritty, almost in the details in which Sultan was describing how we are doing the laboratory group standards. It's really in that level I'm going, but bear with me, there is a pitch I want to make, which I think you will appreciate and will find use of it in your work. So one of the things I share with, when Phil was telling that 5 years, 6 years back, when he first started talking about counterfeit, he thought, well, a couple of years, we'll be done with it, I'll move on to the next task. Very similar thing we have realized. About 7 years back, we put in our one paper in IEEE Spectrum, and we just thought, yeah, it's interesting. People have found it, and people will take care of it in the industry. We are academic laboratory. We will not need to be as involved. But as it turns out, unfortunately, that did not become the case. But fortunately, on the other hand, it became much more than just looking at the font and the logo under a microscope, and issues of material science, issues of forensic failure analysis, where we found a spot for ourselves. And as a test laboratory with doing work for many companies, and also closely working with many other departments of the government, we found a space for ourselves. And again, I hope this does not remain an issue that we have to worry about, and we can spend the time in building better products, but we probably have to deal with it for a while. Let me tell some conclusions first. Most of the time, what I have seen, you have seen, we get hit with counterfeit parts because we did not think about that the parts I had would go obsolete. So there is no real alternative to a good supply chain management and obsolescence management. Having said that, if we haven't done it 10 years back, we still have to do buying things and checking them out. But in my opinion, this buying things and checking them out, although I am closely involved with the process, I hope to be making some contribution to the process, this is not a really great solution, because people get smarter, and just the way we have 55, 53 continuous improvement group, we might have to have 61, 71 continuous improvement group, because things will change. But one thing that does not change and does not allow a counterfeiter to get ahead of us is they are not going to be inventing new materials. Maybe they would, but we are not there yet. They will still have to use industry standard material to do their counterfeiting. However, they are just retrofitting a part, whoever they are getting a die and molding it, they may do it at a very sophisticated lab, at a level at which AMCO does. I mean, I don't know if anybody from AMCO is here, it's Phoenix, so there may be. But they will not be able to get a mold compound from the way back, from the time when the part is supposed to have been made. They would need a time machine for that. that's not going to happen. So my interest in this whole task is to bring in front of you one piece of way of finding. I wish Janice was here because I wanted to have a wordplay discussion with her that you don't have to put on a DNA. A part already has its DNA, and that DNA is its material. So, but I didn't get a chance to do that. She might have a good comeback, but she'll have to wait for it. So that's what I'm going to talk about, and I want to thank DoD. One division of it has sponsored an initial task on this, and I'm yet to submit the full report to them. That's why you will see I don't name the company whose material analysis or data I looked at, but hopefully that will be published relatively soon, and I expect to continue that work with them. So I keep complaining about that you cannot just inspect your way out of counterfeiting problem. And one of the reasons are we say that we don't have a golden part. Actually, if you have a golden part, that can be a worse problem. Why? Let us say I'm buying a 2001 genre PQFP part. That's fine. The golden part I have for that particular part number is from 1998. Between 1998 and 2001, there had been die shrink. There had been changes in the way the wire bond lineup is done. Now I compared them, and my first thing is, oh, I have a problem. Whereas actually, I don't have a problem. Or maybe I don't have a problem. So number one, you do not have a golden part, that's possibility. And number two is you have a golden part, but that's from a slightly different pedigree than the one you are looking at. So that does not always solve your problem. So what I want to do is to present to you a procedure and to come up with certain parts of the certain material which are possible or impossible to be available in a certain time period of that part. Is it going to be an easy task? No. We can handle it two ways. One will be that somebody takes it up as a big project, puts in the manpower, creates this timeline. And number two, when you make up a plan for identifying whether a part is good or bad, you do the background work as it comes and do it. But let me just show you some of the things that to look at. These are roughly the things that we are looking at in the SAE lab group. A bit of visual inspection, there is X-ray, there is material characterization already in there in form of XRF, in form of the miscellaneous group who are looking at FTIR and other things, and also in the die inspection at the end. What we do not have a lot is the material characterization in the form of looking at the constituents of some of the material where we can find a risk. That's the one I'm going to be talking about. Other part, which is not yet there, is the package evaluation. What I mean by that? It's if I have enough samples, when I get in the parts, we should be taking some of them at least through the procedures like qualification tests. So if some parts had gone through that kind of rework in the field, you do a THB test on them, they're going to fail pretty soon. Even if they electrically pass, they're not going to survive those very standard tests because they're used parts or old parts. So, but that's another thing which is not quite in the standard yet, but that's something one should look at. But I'm going to talk only on the material characterization part. So this was a case of a lucky break we had a few years back. I had shown this graph several times. Maybe some of you have seen it before. So a company came to us saying that they are getting the complaint from their customers that when they do capacitance testing after a temperature humidity exposure, it's losing the capacitance very fast. So we just went into first looking at what the material is. And what we found was that it was very low on yttrium, which is in most of the barium titanate MLCCs. There is a trace amount of that that helps in stabilization of the capacitance. So it was here in the very low trace amount, whereas for that same company, the good parts are actually about 1.25% or so. And just as an interest, we looked at a couple of other companies, how much yttrium they have, and that was almost 2.5. So it's not necessarily that you have 2.5, but you definitely need it. So that gave us this idea that, well, I'm not going to be, for these small parts, I'm not going to be looking at part marking or anything. So, but I can do a material analysis and find information. Now, let's take that to the next step. Most of the parts, and here most of the technical slides here I'm going to be talking about molding compound only, but this is clearly not limited only to molding compound. So in a molding compound, in a plastic part, if you look at that items, so there are 7 or 8 different chemical items which are there, and there is a range of percentages, and at the end, it has a list of what kind of typical material that are used there. Those are parts of what I call the DNA of the product. Now let's look at a little bit more detail on that. This is from 1995, a very old one. Just look at the portions in the red. I know it's very small, but you're going to get these slides. You not only have the compound name, of course that's necessary, what kind of resin. They use the term ash content. It's actually the silica filler or the filler content, and several other material properties. So at the very top, I have a couple of chemical signatures, what kind of filler material is there and how much is there. I also have what type of resin is there. And then I have a whole set of thermomechanical properties, the CTE, the glass transition temperature, those kind of items. Now, what I'll take you through, just next 2 pages, let's say epoxy resin, what's the different types of resin, what the chemical structure. This morning, a little bit was mentioned about FTIR, and FTIR is often used to determine what is the type of resin. Now, this is not going to be, although epoxy resin is the most common, but every epoxy resin, depending on their type, will have a slightly different FTIR signature, and you will need access to some form of library for that purpose. But still, if it's a gross change from one type of epoxy to other type of epoxy, you will definitely be able to identify that. Here are the different types of filler materials, and the filler materials themselves and how much percentage you can find out by getting relatively small sample out of a part and determining what the filler material and what the percentage is. And what I showed you a couple of pages back, this is not any detailed spatial data sheet. This is standard information that you can get. And I'll also tell you what other places you might get them to get that percentage of the filler material. So these are the kind of signature I'm talking about. And here is one case of an FTIR analysis where we found difference between a good and a bad part. This particular example was really, we were not thinking of it as a counterfeit issue. We started looking at it as a quality issue for some power semiconductor parts, but it turned out to be a counterfeit issue because people didn't come to us initially as a detect if it's a counterfeit. They came to us, detect why this part is failing faster. So what we did, just to show you how you might be able to do this, we picked a relatively small company because if you look at a TI or analog, there will be 3,000 product change notices in this period, and I will be overwhelmed. So I took a relatively small company, but a company whose parts are used in the DoD quite a bit, and looked at what type of how many PCNs were released between 1996 and 2012. I looked only at GuideApp. Is it possible that there may be a few I have missed? It is. But I think it's pretty well covered. These are the types of changes that we have seen. So you see temperature range change, lid finish change. Two things I'm most interested are the package material change and the mold compound. I'm sticking with the mold compound, but package material change would mean die attach material change, wire bond material change. Those will be the package material change. But mold compound changes, there were 21 of them that came out in this period. Few other things which I found interesting and can be useful, things like change in marking or date code. So just the style of the marking or what is the date code convention that had been and a new thing has come up. Now here is just an example of the type of things. So typically, as you know, in any PCN, they will have why they are doing it, what tests they have done before and after. But at the end, there are some transition dates and what mold compound they're changing from, and sometimes which site the changing is happening. So this is just one example of a PCN that we got. And going through pretty much all of them. This is still example because I could not fit everything in. So there is this different years, the switches that happen from one type of mold compound to other. So with time, and we did this really with part number. So a part number going from 2002 to 2012, assuming that the same part number stay, but within that same part number, depending on the date code, the mold compound changes. And that is the track which I am most interested in. So then I did it for all, just showing you a few samples of the materials change. Of course, there is still the material properties change between the one to other. I did not go into the type of resin or the type of filler, that thing in these tables. I'm just talking about parameters like specific gravity to water absorption, things that are typically reported in a mold compound information, and taking from there what is the level of change and what kind of laboratory equipment needed to evaluate that. So this is for a 2002 case. Another example from 2007, and another example from 2008. So am I saying it is always easy? No. Actually, in this particular case, it's going to be really difficult because just with the material properties, because you see there is very little change. In the previous cases, I had a glass transition temperature change from 140 to 130, 10 degrees, reasonably significant. Here I had 25 degrees, significant. But here I have, except the water absorption, which almost doubles in the new one, other things are. So depending on which property will be of most interest, we'll have to devise a test methodology where I can compare, okay, maybe for this part, I want to check the water absorption as the test that I can do. All of it will depend on how much time you have, which will be the fastest way to do. It will not be one prescriptive that you go through that 1 through 9 and all done. We'll have to go one by one, but it is really one case. If I get a part today which is claimed to be made last year, but it tells me it's really that 2002 Shin-Etsu molding compound, it's matching with those properties, I know it's a problem. Can I take it to a court of law and hope that the jury understands all of it? I don't care. I am an engineer. I have to make a decision whether I use the part or not use the part. If it needs to be proven counterfeit by some other method, that's fine. But if I find that level of a risk, I will put a mark on it and try to see my next source. So where do you find those information? There's those tables that I populated. And you have noticed probably some of the pieces I could not populate. Of course, the first item is the mold compound manufacturer's data sheets. That works. There is one big problem. We have had an absurd amount of consolidation in the mold compound industry. So depending on those companies' policies and all, some of the older data sheets are not always available. So I thought, that's too bad. But then I found many of the component manufacturers, particularly the information hoarding, sharing kind of component manufacturers, their websites are like my desk. They don't throw anything away. And you go back to the qualification report of a part made by one of those companies from 20 years back, they actually do list the mold compound properties that they considered. Sometimes when they're reporting the PCN itself, in the PCN itself, they will report some of the properties comparison with the old molding compound and the new molding compound. That became a very good source. MSDS, material safety data sheets, typically they will not have the thermomechanical properties, but they would, depending on the reporting requirement, they will often have the chemical structures of the key materials which are in there, even sometimes with the bond structures. That's a good source. Old books. I mean, being from the university, I never have run out of old books. And old journal papers, where people are reporting about mold compound related research work, they're often reporting these properties. So it is not a task that's impossible in any manner if you put the time to it. And you have to think of it two ways. If you are just thinking of it for your company, one part came to your door, you are evaluating, you don't have to do it for the whole world. You just do it for that part number. So it's definitely the possible way. Although I would love to have an industry consortium help us put the manpower into it so that we can build a bigger, more comprehensive database of not just mold compound, but possibly die attach, lead finish material and item, wire bond material and items of that kind. Now, just as an idea, this is not the thoughts of this and this kind of analysis is not limited just to mold compounds. Printed wiring board materials, they are also collection of chemicals. And there again, many times we don't buy components, but we buy boards. And that's one way to check. I didn't really put a detailed thought on it, but there is a lot of chemicals in here which went through the very similar kind of timeline change process. I won't go through it. Advertisement, I do it. These are the kind of things we offer. So just because we're an university, do not assume that only when you have a problem of a thesis material, that's only when you talk to you. No, we do, and people who have been working with us for a long time know. We just do not know where the ivory tower in our university is. We work with everybody on making a component management plan, to testing of material, or to come up with what I just showed you for particular product of your interest or material of your interest. So our lab, again, is all of you are welcome if you're in the Washington, D.C. area to visit. We are very proud of our labs and would love to show you. SAE has been very helpful in sponsoring this event in the last few years and promoting. So I'm hosting this pretty nearby from here in Anaheim in a couple of months. Oh, not a couple of months, only a month. Next month. So if your colleagues are in the area, if you're interested, you can contact me or go to the SAE website. I think this is, I want to thank the CAL sponsors who overall help us continue to do this work, because some of these things we pick up, just the ones I showed, until the time we had some support from DOD, we were kind of doing this on our own, and we continue to do so. With that, this is the end of my talk. We are holding the questions for the end, right?
Yes.
Okay. I'll be happy to answer other questions from you. Thank you.